Hey friends, we're doing Introduction to Permutations and Combinations. So permutations and combinations are, what they are a probability friend. They live with factorials. And what they are, I'm going to go down here a little bit here and just start some notes. I'm going to do permutations on this side and combinations on this side. And when we do a probability, if we say like the odds of me ever becoming the president are like 1 out of 1,000,000, okay? This part of that odds of the probability, that was found by either doing a permutation or a combination or some form of that, okay? Permutations and combinations are what make up the bottom part of our probability. It's how many total ways there are to do something, okay? And we even sometimes use them to find the top part, okay? So they're how we find how many ways there are to do something. All right, so let's figure out how we use it then. So let's say we've got 3 students. Oh, well, first of all, let's give the rules for it. We're going to put our students down here. Permutations are when order matters. And sometimes they're going to use the word relevant, which is another word for matters. Okay? And combination is when order doesn't matter. And so they'll say not relevant. Okay? All right, so let me give you an example. Here's my example. I have 3 students. Let's say I've got Ava, Bob, and Fred. There we go. Ava, Bob, and Fred. And from Ava, Bob, and Fred, I want to find out how many ways Ava, Bob, and Fred could be president and vice president of our math class. How many different ways they could be it, okay? So let's see. We could have Ava as president and Bob as vice president. Or I could have Bob as president and Ava as vice president. I have Bob and then Fred, or Fred and then Bob, Ava and then Fred, or Fred and then Ava. So there are 6 different ways that we could have these 3 people be president and vice president of our class. Okay? And then if I was to take it one step further, well, we'll go there in a second. Okay. So this is, no, I'll go over here. Now, if I were to do a combination with them, we'd say how many different ways could I send 2 students to a convention? Well, I could send Ava and Bob. I could send Bob and Fred. Or I could send Ava and Fred. Now, would it be different if I sent Bob and Ava? No, it wouldn't, because they're already up here. They've already gone to the convention. It's not different, not unique. They've already gone. They were a group. Okay? Grouped together, okay? So when they're grouped together, the order doesn't matter. So there are 3 ways to group them, to send them to a convention. So in combinations, order doesn't matter. But in permutations, order does matter, because over here, Ava and Bob versus Ava, it probably matters a lot to Ava to be president versus vice president. There's probably a role that she would prefer, or Bob too. So those are two very different options. So you're going to see permutations. Let's see, typical examples. For permutations, you're going to see like president, vice president, secretary, or first, second, third place in a race. Okay? That's what you're going to see over there. And you're going to see those words where it's order is relevant. And then over here, you're going to say order not relevant. We're going to see situations where they can go as a group. Okay. Now, one thing I want to point out, like in a situation like this, soon they're going to go also into probabilities. They're going to say, what's the probability that Ava is president? Well, she was president here and she was president here. That would be 2 and 6. See, there's that 6 on the bottom. We knew that there were 6 total ways to do it, and 2 of them, she was president. All right. So now let's do the math. Let's talk about the equations for them. For permutations and for combinations. For permutations, the equation is n factorial over n minus r factorial. And for combinations, it's n factorial over r factorial, n minus r factorial. And for both of them, n equals number of objects taken r at a time. That one's worth you. If you want to pause it, you can write it down. And I'm going to show you how to use these. However, there is an easier way. Well, of course, I'm spelling it wrong, but easier way. NPR and NCR. Here they are. They're in our calculator. Your calculator has this button. I promise you it does. If you have a calculator in your backpack, you have this button. If you don't know where the button is, come find me. I will show you where it is. Your calculator has this button. There we go. In this calculator, it is under math. So if you hit the math button right there, and then arrow across the top to the probability, there they are, NPR and NCR, right there. So I'm going to show you how to use those now. So let's go down here. I'm going to insert a problem right here. All right. I'm going to make it big and crop it a little bit. There we go. Okay. Cool. All right, first problem. It says, suppose we want to choose 2 objects without replacement from the 5 objects: pencil, eraser, desk, chair, and lamp. Okay, the without replacement just tells us that once we choose one, we're not putting it back. There's 5 total objects, so that's our N, and the 2 is our R. Okay, So how many ways can this be done if the order is relevant? That means order matters. That means permutations. Okay, if we're doing permutations is n factorial over n minus r factorial. So that would be 5 factorial over 5 minus 2 factorial. So that is, on the bottom we've got 3. And on the top, I'm going to expand this 5 times 4 times until I get to the 3, and then I'm going to leave that as a factorial. I know they like do it all the way down to 3, 2, 1, but these are the same things, so they can cancel. 3 factorial over 3 factorial. They're gone. And that is 20. So our answer is 20. Let me show you that in the calculator. Again, I'm going to go in here and show you where that button is. Again, math right there, math button. I'm going to arrow across the top to probability, or just click that button. NPR is the second button there. And it has a box on each side of the P. P for permutations. The first number you're going to put in is the big number, 5. 5 objects taken 2 at a time. There's my answer, 20, 5P2. All right, and then my next one is not relevant. That means combinations. And that math looks like this. Combinations is n factorial over r, n minus r. There we go. So we've got 5, 2, 5 minus 2. All those factorials. So I'm going to do this one here, 2 times 1. This is going to be 3, and 5, 4, 3. There we go. Kind of see those coming. I like to cross them out. They make me happy. I get 20 over 2, which is 10. Combinations should always be less than permutations. Always. There should always be less options in combinations. I'm going to grab my calculator and double check it. Math, probability, NCR. 5, 2, 10. There we go. All right. If that's confusing at all,